Hi there, this is N5.1, represent, compare, and describe whole numbers to 1 million within the context of place value and the base 10 system and quantity. So what we're looking at here is not really big numbers. We're just going to 1 million, that's what the digit there means. And this whole outcome is all about place value. And the base 10 system, remember those blocks that we've used before, ones and tens and hundreds and blocks of 1,000? So we'll be using those as well. So the outcomes say that you have to write and say, so you have to be able to write the number and read it out loud, using proper spacing without commas. Back when I was in school, we used to use commas, and now they've done away with that. Commas are illegal, don't use commas. And we can also no longer say the word and. So when you read a big number, like they've got here, you would say 934,567. And they've got that written out right there. Critique, and critique means tell what's good about it or what's bad about it, or if it's true or not. Critique the way numbers have been said or numbers have been written in examples found in various types of media and personal conversations. So if you listen to me long enough, I'm probably going to use the word and I'm probably going to write it with a comma because I'm an old dog and that's just how it is. But for you new folks learning how to write big numbers, don't use and, don't use commas. The next one, describe the patterns related to quantity and place value of adjacent. Adjacent means right beside each other. Okay, so when you look back up to the number that we just used, the 9 and the 3 right here are adjacent. They're right beside each other. So what does that mean? How are those two digits related? And what place value do those adjacent digits have? If you move from right to left in a number, what does that mean? And if you go the other way, what does that mean? So we will talk about that in a minute. Visualize and explain concrete or pictorial models for the place value positions of 100,000 and 1 million. Describe the meanings of quantities to a million by relating them to yourself, your family, your community. We always have this outcome. Self, family, and community is in almost every outcome in math from grades K to 12, I would imagine. Explain the contribution of each successive numeral position makes to the actual quantity. So they want you to find examples of these great big numbers in your family or in your community. Maybe you're winning the lottery or something like that. You would need to know how to read those great big numbers. Pose and solve problems that explore the quantity of whole numbers to a million. A student might wonder, how does the population of my community compare to those of surrounding communities? Well, the population of Fillmore is nowhere near a million, but there are certain populations that are that big. For example, I think the population of Saskatchewan right now is about 1 million. Provide examples of large numbers used in print or electronic media. Explain the meanings of the numbers. So you're going to see numbers on websites and maybe in the Olympics or things like that. You will see big numbers and you'll need to know how to read them. Visualize a representation of a given number, and I've got a pretty cool little experiment for that. We'll see how you do with that one. Explain how the representation is related to the number's expanded form. So there's one of those words from our word wall, expanded form. And actually they've given an example of it right down below here. Express a numeral in expanded notation. So if you have a number like 45,321, look at that, I didn't even say and. So good. Anyways, you can break that down in a way that shows what each digit means. So what does the 1 mean? Well, the 1, look down here, it's in the ones column, so that just means it's 1 times 1. What does the 2 mean? The 2 means it's in the tens place, so there are 2 tens, so that's 2 times 10, and that means there's 20, right? The 3 is in the hundreds, so 3 times 100. The 5 is in the thousands, so 5 times 1,000. The 4 is in the 10,000s, so it's 4 times 10,000. And I'll show you a different way to break that down on the next few pages. And then they've just taken their totals and said, well, that's 40,000 plus 5,000 plus 300 plus 20 plus 1, and that gives you this big number here. Compare and order examples of whole numbers found in various types of media and print. So that one sounds an awful lot like a couple of outcomes ago, or indicators ago. So let's look at our next slide. Okay, so here is a ginormous number. This number is actually bigger than the one that your curriculum says you have to learn about. This is much bigger than 1,000,000. Your curriculum in grade 5 says you only need to be able to read a number up to the millions. But for those of you that like a challenge, I've included a few extra digits. So I'll show you how this works. If you're going to read a really big number, the trick is you have to get your number organized first. So how you organize a number, you look at the right side, the very first digit, or the last digit, I guess. This is in the ones column, right? We have a 1 in the ones. What's next? The 8 represents the tens, and the 7, nice straight line I got going there, yeah, represents the hundreds. Okay. I'm going to call this group a family. Aren't they nice? Okay, this is a nice purple family. It has 3 members. It has a hundreds, a tens, and a ones. So what number is in this family? Well, 781. Now, unfortunately, this family doesn't have a last name. We always joke and call them the nobodies. If you were going to read, I'm just going to go down to the bottom here, or just watch in red. If I gave you this number and told you to read it, you would say, oh, that's easy. It's 781. Notice how they didn't have a last name. It wasn't 781 million or 781 billion. It's just 781. That's it. Okay, so let's go back up to the top. I'm going to find our next family. Every family has 3 digits. Okay, it has a hundreds and a tens and a ones, just like the purple family. However, this family has a last name, and they are the thousands. So, see what I have circled in red? 825,000. Give them their last name. Okay, on to the next family. Make them green. This family has 3 members, same as every other family. And they are the hundreds, the tens, and the ones. This family's last name is million. And our last family, they don't have 3 digits like everybody else. They only have a tens and a ones, because there's nothing in the hundreds column. So their last name is billion. Okay, so that took a long time, but we've got our great big number organized, and it's organized into families. I started at the right side, and I grouped everything into 3. Now, your curriculum, remember I said when I was in school we put commas in between? Your curriculum doesn't want you to do that. They want you to put spaces in between. So you write your billions family, leave a space. Write your millions family, leave a space. Write your thousands, leave a space. 781, and there's your nobodies. So this is how you would write this number. And here's how you would say it. 59,309,825,781. Look at that, I didn't even use and. So good. Okay, I'm learning, this old dog. Let's go to our next slide. So here is our big number, and we're just going to go through that whole explanation again real quick. You arrange your families into groups of 3, and you see I've left a little space between each family this time, starting with the nobodies. Now this is one of the misconceptions, is some people forget and they try and start on the left side where the billions were, and they try and group these 3 numbers together, and then these 3 numbers together, and then these 3, and then they realize at the end they have 800 and, wait a minute, there isn't 3 members in the nobodies. So you always have to start with that end. Now let's see if I can erase what I've just drawn here. Probably not. Ah, look at that. Okay, good deal. So always remember, start with your ones, starting with the nobodies. Decide what families you're working with. Get their names ready in your head. So we have the nobodies, they don't have a last name. These are the thousands, these are the millions, and these are the billions. Remember, your curriculum only asks you to go up to this spot, but the grade 6s could watch this video, or the grade 7s, or if you feel like reading much bigger numbers than a million, now you can. So, got the names ready in your head? Now we're going to say each chunk. So here's a chunk, that's 59. Here's another chunk, that's 309, 825, and 781. So get each chunk ready and their last name, starting from the left side. Okay? And here we have it written down here. 59,309,825,781. All right, remember these base 10 blocks? I said they'd be coming up, and here they are. Now, I've got a number down at the bottom, and this is a smaller number than what we just worked with. It still has 781 nobodies, and the 5 is in the thousands. Okay, so if I had 5 of these big blocks, 7 of these hundreds, 8 of these rods, and 1 of these guys, which we do, I would have my big number of 5,781. Now, expanded notation means that you're going to write each number, each digit, and the place value that it's in. What does it mean? So if the 5, I'm just going to change colors to green, if the 5 down here is in the thousands spot, what that means is there's 5 of these blocks, and each of those blocks has 1,000. The 7 is in the hundreds spot, so that means there are 7 of these plates of 100, meaning 700, right? It means that there's 8 in the 10 spot, and there's 1 in the 1 spot. So that's what they've written over here. Well, what is 5 times 1,000? If I have 5 of those blocks, how many do I have? If you said 5,000, you are correct. What's 7 times 100? 700. What's 8 times 10? 80. And 1. And when we add them all up, there is our answer. Okay, here's that number line we were talking about. And this is my chance to trick you. Ha ha ha. Actually, if you guys figure this out, you can go trick your parents. That'd be super fun. Okay, we are going to find, if I have a number line and this is 0, this down here is going to be a real big number. Are you ready? This last stake on the number line is not 1. It is not 1,000. It is not a million. It is in fact 1 billion. So if I look at our numbers, our zeros, here are the nobodies, here are the thousands, here are the millions, and this digit right there means 1 billion. Now, if you'll notice, I did this wrong. I put commas in. Oh my gosh. Number line police are probably coming for me right now, so we'll make this video quick. Don't put commas in your numbers, like me. All right, so our number line goes from 0 to a billion. It's a big number line. Your task is find a spot on the number line where you think 1 million is going to live. Tricky, hey? How would you put a million on this number line? Where do you think it lives? So let's do some guessing. How many people think it lives about here? Or maybe it's more than that, and it lives down here. Or maybe it's much less than that, and it lives here. Or maybe it's even less than that, and it lives here. Or maybe it's much, much more than that, and it lives, oops, here. Okay, so here's some guesses for you. I've got dots all over the place. Which one of those dots do you think represents 1 million? Got a guess in mind? Okay, so let's actually figure this out. Well, let's look at that light blue dot. It's right in the middle. It's right in the middle between 0 and a billion. So if I were to cut the number line in half, this would represent half a billion, right? Well, a half a billion is nowhere near 1 million, so we know this is way too big. So we know that everything on this side of the number line is not going to be used. A million is not this way. This blue line represents half a billion, which is actually 500 million. Look at all those zeros. Okay, that's 500 million. Well, we don't want 500 million, we want 1 million. So let's split her up again. Let's use green this time, and a skinnier pen. If I took this distance from 0 to 500 million, and I chopped it in half, right about there, that would represent 250. My gosh, the commas, I just can't stop. Okay, 250 million. Well, again, we're nowhere near 1 million. We're at 250. So we have to chop that in half one more time. Let's chop that in half. Now we're looking at 125 million. Okay, any guesses as to where 1 million is lying? If I were to take this number line and chop this space from here to here into 125 pieces, chop, 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 a lot of pieces, 1 million is actually right about there, where my green drawing is happening. So it doesn't even probably make it to the gray circle. That, ladies and gentlemen, is 1 million. Now, the reason that I put 1 billion down on the end is I wanted to show you that this little green sketch right here, where 1 million is lying, is much closer to 0 than it is to a billion, because 1 billion is 1,000 times bigger than a million. Okay, so why do we need to know these great big numbers? Well, what if you wanted to know the number of internet users in the world? What if you wanted to measure, if you were a scientist and you wanted to measure the total wolf population of North America? You're going to need numbers into the millions and possibly into the billions. The amount of seconds in the human lifespan, the age of the Rocky Mountains, the distance to the sun, Donald Trump's campaign budget, probably bazillions, yes. What comes after billions? I'll give you a hint, it's not bazillions, that's just a word I love to use. I think they should have named it bazillions, but they didn't, so I didn't get my way. What comes after billions? So I'll leave that to you. Go and look those up and see what families come after the billions. You could probably also look up Donald Trump's campaign budget. Let's see how much that guy's spending.